Today we're looking at lesson 5-6, which is graphing inequalities with two variables, and most likely you're going to be using x and y. So the graphing part of this is actually not graphing on a number line, it's graphing on a coordinate plane. So there's 3 steps to follow. The first step, they said, is graph the boundary. What that means is basically you're just going to graph the equation they give you, make sure it's in slope-intercept form, and graph it like you would if it had an equal sign. The only difference is if it has a particular sign like less than or equal to or greater than or equal to, you're going to draw a solid line, and where you would normally draw your solid line. So that actually doesn't change any process of graphing an equation that we've already gone over. The only difference is if you have a less than symbol or just a greater than symbol, that is going to make a dashed line instead of a solid line when you graph the equation. Next, you're going to use a test point. As long as the test point is not on the line that you drew, it can be any point on the graph, and you're going to plug in the test point to see if you're going to if you're going to shade one side or the other. And that's your third step, is shade. So we're going to go over these 3 steps for a few different examples here. First is graph y is greater than 1/2 x plus 3. So I'm going to graph this like I would if it was y equals 1/2 x plus 3. So it's already in slope-intercept form. So I'm going to draw my graph. Of course, you're going to use graph paper and start at 3, and then you're going to go down. Oops, let's change the color. You're going to go down or up 1, because the slope is positive 1/2, up 1 to the right 2. Or you can go down 1 to the left 2. Then I'm going to look at which type of symbol I have, and since I don't have an equal to line underneath my symbol, my line is going to be dashed through these points. Now I need to pick a test point, and usually I say pick 0, 0 unless you have the line going through 0, 0, then pick any other point. But I'm going to pick 0, 0, and I'm going to plug in 0 for y in my original inequality, 0 for x, and I'm going to see if this makes a true or false statement. So 0 is greater than 1/2 times 0, which is 0, plus 3, so 0 greater than 3, that is not true. So that means I'm not going to shade my graph towards the 0, 0, I'm going to shade away from the 0, 0. So in this case, it's all this upper section that I'm going to shade. And that would be my graph. That's my final graph. The next one we're also going to graph, but notice this is not in slope-intercept form. Oh, actually it is. It's just reading it from the other side. So this reads y is less than x minus 1. So I'm going to graph y equals x minus 1, which means I start on the y-axis at -1. And my slope is 1, so I go up 1 to the right 1, and so on. Now I check to see what type of symbol this is. Since it doesn't have an equal to line underneath, this is again going to be a dashed line through my points. And since I didn't use 0, 0 as part of my line, I'm going to use 0, 0 for my test point. So I plug in 0 for y, 0 for x, and I compare, is 0 less than -1? That is false. So again, I'm going to shade away from 0, 0, since it's a false statement. Again, I'm graphing this. I need to make sure this is in slope-intercept form, which it is not. So I have to move the x first, keep the symbol, and then I'm actually dividing everything by a -1. And even if I'm doing it in this process, I still need to flip the symbol when I divide or multiply by a negative. So I get positive x over 1, or just x, minus 3. And that is what I'm going to graph, or at least I'm going to graph y equals x minus 3. So I start at -3 on my y-axis, and then I go up 1 over 1 for my slope. And this time I have an equal to line underneath my symbol, so that means I need to draw a solid line through my points. I can use 0, 0 as a test point since my line is not going through it. So I have 0 is greater than or equal to 0 minus 3. Is 0 greater than or equal to -3? Yes. So that means I'm going to shade this time towards the 0, 0 on my graph. So this whole top section here. More of the same. Again, though, we don't have this in slope-intercept form, so we're going to move the x value over. Don't flip the symbol. And divide everything by 3. Since this is a -3, we keep the symbol the same direction and just simplify. So what this tells me is that I'm going to start at +6 on my y-axis, and I'm going to go down 2 to the right 3. So start at 6, down 2 to the right 3, down 2 to the right 3. This is going to be also a solid line because of my symbol being equal to also, so it does not have a dashed line. Then I can pick 0, 0 as my test point, so 0 is greater than or equal to, plug in 0 for x. So 0 is greater than or equal to 6, that is false. So again, I'm shading away from 0, 0, which is all up here. Here we're asked to use a graph to solve. Quite frankly, I would solve for x first and then use the graph to check. So 4x is greater than or equal to 20, divide by 4, so I have x is greater than or equal to 5. So my graph should have x equals 5. And what I'm going to check is if the shaded area is in where the 5 is. So if that's true, then it's correct. So x equals 5. So I'm going to draw a solid line through x equals 5. I can use 0, 0 as my test point, so is 0 greater than or equal to 5? That's not true, so I'm going to shade away from 0, 0. Which would tell me that all the shading part is greater than or equal to 5, so my answer should be correct. Again, solve for x here first, if you just have an x. Since you're dividing by a negative, that should be flipped, so x is less than -3. I'm going to be graphing x equals -3. That's going to be a dashed line since we don't have an equal to line underneath the symbol. I can use 0, 0, so 0 is less than negative 3, which is false. And again, that would mean I shade away from 0, 0. And if I look in my shaded area, all of this shaded area does not include negative 3, but it's all in the less than area of the graph. So that means my answer, x is less than negative 3, is correct. And we have one more. This is where we're going to write and solve the inequality, or write and graph the inequality. So I'm looking for, if slope-intercept form is what I'm using, I'm looking for a rate, and then I'm looking for the symbol in this case since we have an inequality. And I can find it right here where it says, Nell wants to run a marathon at a pace of at least 6 miles per hour. So that is going to be part of my equation. Since it's per hour, it's going to be 6 times x, and x is my hours. I know it's at least, so that's where I get the greater than or equal to 6 part. And then I put my y on the other side, which represents the total miles. So I'm going to graph this. I need to put starting point at 0, 0, since my y-intercept is 0. And then I'm going to go up 6 to the right 1. I can put another point there. Oops. And then I'm drawing a solid line through my points. Since my sign has an equal to line underneath, it's a solid line. I cannot use 0, 0 in this case, but I can use 1, 1. I can't use 0, 0 because 0, 0 is on the line that I drew. So if I used 1, 1, 1 goes into y and x. So is 1 greater than or equal to 6? No. So 1, 1 is to the right here, so that means I'm shading all the area to the left. And that would be my answer. That concludes Lesson 5-6 on graphing inequalities in 2 variables.